A unit circle is called a unit circle because it has a radius of 1. If we look at this like a coordinate system, this is x and this would be y. And x is associated with cosine, while y is associated with sine. If we add the degrees right here, cosine of a degree will give you the x value associated with that degree, while the sine of the degree will give you a y value associated with that degree. So, a unit circle, we know, is a circle that has a radius of 1 units. So the maximum value that the x and y could be for a unit circle is 1. It can't be greater than 1. Other options, I'll list them in ascending order, is 0, 1/2, square root 2 over 2, square root 3 over 2, and 1. And we're going to complete the unit circle. So we have a circle, looks like a pie for a reason. It starts at 0 degrees, and we know this is 90 degrees. We know this is 180, and we know this is 270. So we have 90 plus 90 becomes 180, plus 90 becomes 270, plus another 90. We're back full circle to 360. We also know that at 0, this is 0, right? In radians. And at the 90 degree, we know it's pi over 2 in units of radians, and here is pi, and here is, so since that's 1 pi over 2, that's 2 pi over 2, which equals to pi. This is 3 pi over 2, and we add another piece of pi, becomes 4 pi over 2. In other words, that's 2 pi. Okay, so once we're back full circle, we're at 360 degrees, or 2 pi radians. Now, to complete the circle, we're gonna further slice that pi, and we know that's 30 degrees, and that's also in radians it would be pi over 6. This 30, this piece and this piece is equal, and each is equal to 30 degrees. So 30, to get to here, we add another 30, we get 60 degrees. Same with the radians. If that's pi over 6, we add that would be 2 pi over 6. In other words, we can simplify, becomes pi over 3. So 60 degrees is 2 pi over 6, or pi over 3 radians. I should probably leave some space later for when we do the 45 degrees. So pi over 3. Okay. Now, we want to know what this is. We just add another 30. So 30 plus 30 gives us 60, plus another 30 gives us 90, plus another 30 gives us 120. Plus another 30 gives us 150 degrees. Plus another 30 comes 180. We continue to slice this piece of pie equally. So we add another 30 to 180, becomes 210, 240, 270, 310, and 340. Now, we can go back and add the radians. So in units radians, 120 is, let's see. So since that's pi over 6, we add another pi over 6, becomes 2 pi over 6. That's 3 pi over 6. And I can prove that. 3 pi over 6 simplifies to pi over 2, right? So since that's pi over 2 is 3 pi over 6 at 90 degrees, this would be 4 pi over 6. This would be 5 pi over 6. This would be 6 pi over 6, which is pi. 7 pi over 6. 8 pi over 6. 9 pi over 6 simplify becomes 3 pi over 2. 10 pi over 6. 11 pi over 6. 12 pi over 6, or becomes 2 pi, right? Now, you can see the pattern here and how we came up with those numbers. So then now we can go back, since you understand how we got there, we can go back and then simplify it. So 4 pi over 6 is just what? Simplify 4 pi over 6 is just 2 pi over 3, right? That becomes 2 pi over 3. And 5 pi over 6 cannot be simplified any further. 7 pi over 6, the same. 8 pi over 6 can be simplified to 4 pi over 3. So let's do that. 4 pi over 3. And then 3 pi over 2, okay. 10 pi over 6 can be simplified to 5 pi over 3. And then 11 pi over 6 can leave it just like that. And then we're back full circle. Now, we're going to move on and add the 45 degrees. And 45 degrees is just pi over 4. And if we want to get to here, since this is just equal to this piece, we add another 45, we get to 90 degrees. We add another 45, we get 90 plus 45, we get 135. We add another 45, we get to 180. Add another 45, we get 225. And then add another 45, we get to 270. Then cut right in the middle, add another 45, we get 315. In terms of radians, so 45 is pi over 4. That's 1 pi over 4, right? That's 2 pi over 4, or simplified to pi over 2. 3 pi over 4. 5 pi over 4. No, I mean 4 pi over 4, which simplifies to pi, okay? 5 pi over 4. And add another pi over 4 becomes 6 pi over 4, which is 3 pi over 2. Add another pi over 4 becomes add another pi over 4 becomes 7 pi over 4. Add another pi over 4 becomes 8 pi over 4, which is just 2 pi, right? So that's how we came up with the degrees and radians, and we have completed the unit circle. Now, we want to know like the coordinates. We know that at this point, y is 0 and x is 1, right? So x is at its maximum, which is 1 for a unit circle, and at this point y is 0. At 90 degrees, y, it's at its maximum value, 1, but x is at 0. Jump over to this side. We're at the negative x side, so we have negative 1 and 0. Down here, we have the negative y side, so we have 0 and negative 1. Now, what about the 30 degrees? At 30 degrees, well, first, if you notice, as we approach the 90 degrees, where y is at its maximum value, x is decreasing. Meanwhile, y is increasing, approaching 1. X is decreasing from 1, while y is approaching 1. So, here at 30 degrees, our x value, or our cosine 30 value, is square root 3 over 2. Meanwhile, our y value, or our sine 30 value, is equal to 1/2. And at 45 degrees, both our x and y is equal. See how it's cut right in the middle equally among both pieces. So now 60 degrees, we know here we have our y value greater than our x value, and it becomes 0 and 1. At 120 degrees, it is symmetrical, and the value is almost similar to our 60 degrees. However, we're on the left side where x is negative, so we can copy over the values for our 60 degrees, except for now we gotta tag a negative sign in front of our x. And at 135, symmetrical to our 45, except for now it's a negative square root 2 over 2, square root 2 over 2. At 150 degrees, symmetrical with the 30, but with a negative in front of our x. Now, moving down here to the third quadrant, we have both our x and y negative. So both will be negative. We gotta have to add a minus sign for both x and y. If we trace the 210, it's similar to the 30 degrees. So we have a negative square root 3 over 2, and a negative 1/2. And if we trace our 225 degrees, we reach the 45 degrees, so the values would be similar, except for we're gonna now have to tag a minus sign for both x and y's. And at 240, we can trace it to 60 degrees, so the values would be similar, but now with a minus sign in front of our x and y value. And finally, on the fourth quadrant, where only the x is positive while the y is a negative. So we can trace the 310 to 120. We get a positive x, a negative y. And the 315 we can trace to the 135, but now with a positive square root 2 over 2 and a negative square root 2 over 2. And then the 340, can trace it here to the 150, gives us positive square root 3 over 2 and a negative 1/2. So there, we have now completed the unit circle. So you see the pattern, and we don't have to memorize it if we understand it. One more thing to remember is that all students take calculus. Means that all in the first quadrant is positive. In the second quadrant, only the sine is positive. In the third quadrant, only the tangent would be positive. And in the fourth quadrant, only the cosines would be positive. What I mean is by, for example, in the first quadrant, if you do a sine, a tangent, or a cosine of any degrees in the first quadrant, you'll arrive at a positive value. For example, if you were to do cosine 30, you would have gotten square root 3 over 2. If you do a sine 30, you would have gotten a value of 1/2. If you were to do a tangent 30, which tangent is just, since tangent 30 is just equal to sine 30 over cosine 30. And since sine 30 is 1/2, cosine 30 is square root 3 over 2, you'll get square root 3 over 3. In the second quadrant, only the sines would be positive. If you do a sine 150, you would get 1/2. If you were to do a cosine 150, you would have gotten a negative square root 3 over 2. If you were to do a tangent, and since tangent is sine over cosine, if your sine is positive and your cosine is negative, a positive over a negative would have given you a negative value for your tangent. Okay, and in the third quadrant, we have tangent. Only the tangent would be positive. If you were to do a sine or cosine of any degrees in the third quadrant, you would have arrived at a negative number. But since tangent is sine over cosine, if your sine and cosine is negative, your tangent value would become positive. And finally, in the fourth quadrant, only your cosine values would be positive. If you were to do a sine, you have gotten a negative value. And if you were to do a negative sine over cosine, you have gotten a negative value for your tangent as well.